Okay, now we are going to look at drawing network diagrams. So a connected graph is where every vertex is connected via an edge. So we can look down here and we can see that A, B, C, and D in all three of these diagrams are all connected. We can get from D to B via DCB or DACB. We can get from A to B from ACDB. And we can get from A to C by going straight across or from going to B or D first. So all nodes are connected together by edges in all three of these diagrams. So these are all connected graphs. Now an isomorphic graph is where you are comparing networks which may look different, but in terms of their edges, their vertices, and their degrees, they are the same. For example, let's have a look at these three network diagrams down here. And firstly, you would count up how many edges they are. So in the first diagram, we can see that we have 1, 2, 3, 4, 5 edges. So we have to make sure the next two diagrams both have 5 edges to be isomorphic. So let's count up. 1, 2, 3, 4, 5. So some people may get confused in graph 2 because they might just go from A to D as one edge. However, you have to consider that node C breaks up that edge. And so there is another edge in here, and you have to count that. So A to C is 1, C to B is the second one, B to D, third, D to C, 4, and A to D, 5. And in our third network graph, we have 1, 2, 3, 4, and then 5. So these all have 5 edges. So at the moment, they are all isomorphic. Now, we have a look at nodes, and you count up how many nodes they have. So in the first network graph, we have 1, 2, 3, 4 nodes. In the second, 1, 2, 3, 4 nodes. And in the last, 1, 2, 3, 4. So at the moment, they all have the same edges and the same nodes. Now we have a look at degrees. So in vertex A, in the first graph, we have a degree of 2. In vertex B, we have a degree of 2. Vertex C, we have a degree of 3, and vertex D, we have a degree of 3. Now, if we're looking at the second graph, we have to make sure our A and B both have a degree of 2. 1, 2, 1, 2. So they are isomorphic. Now we look at C and D, and C and D had 3, 1, 2, 3, 1, 2, 3. So C and D also match the C and D from the first graph with a degree of 3. Now we have to compare the last graph to the first two. So they have to have A and B have to have a degree of 2, 1, 2, 1, 2, and C and D have to have a degree of 3. 1, 2, 3, 1, 2, 3. We also must consider that each edge is the same. So we have to consider that A and D connect, A and D connect, A and D connect. We have to consider A and C connect, A and C, A and C, A and C. We have to consider D and B, D and B, D and B, B and C, B and C, B and C, C and D, C and D, C and D. So all the edges connect to the same nodes on all three graphs. There are the same number of edges on each graph, the same number of nodes for each graph, and the nodes have the same degrees for each graph. So all three of these graphs are isomorphic because in terms of edges, nodes, and degrees, they are equivalent. So now we have to identify which graph is not isomorphic to the others. So firstly, let's count up how many edges we have. 1, 2, 3, 4, 5, 6, and 7. So graph 1 has 7 edges. Graph 2 has 1, 2, 3, 4, 5, 6, 7. 3 has 1, 2, 3, 4, 5, 6, 7. And 4 has 1, 2, 3, 4, 5, 6, and 7. So all have 7 edges. Now we consider the vertices. How many vertices do they each have? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. They all have 5 vertices. Now we need to consider what degrees for each node. So graph 1 has 3 for A, 3 for E, 3 for D, 2 for C, and 3 for B. Now we consider graph 2. And node B only has 2 degrees, whereas in graph 1, node B had 3 degrees. So one of these are not isomorphic to the others. So we have to see whether it's 1 that's not isomorphic or if it's graph 2 that's not isomorphic. So now we'll look at node B for the other 2. And node B for the other 2 have 3 degrees. 3 degrees. 3 lines coming out of node B, so 3 degrees. Which means graph 4 and 3 are equal to graph 1 because B has 3 degrees in graph 1. But in graph 2, B only has 2 degrees. So graph 2 is not isomorphic to 1, 3, and 4. You can also have a look at which ones are not isomorphic by looking at the edges. Graph 2 lacks the edge between B and E, B and E, B and E that every other graph has. There is no direct connection between B and E. There is a direct connection between C and E, whereas in the other graphs, there is not a direct connection between C and E. And so in terms of degrees and in terms of what edges connect to what nodes, graph 2 is not isomorphic to the other 3.